we'll do a quick, very simple example about one very simplified way of calculating rain loads on a building. When there is precipitation like rain, in this specific case, what you look at is basically the expectation of the rainfall on a flat surface, even if the roof is sloped. And in fact, flat roofs are supposed to be sloped even just a little bit to make sure that water is directed either to internal drainage systems, or external ones like scuppers. So in this case, let's say if we have a precipitation of some sort, let's pretend this is Ottawa, according to the Ontario Building Code. And in order to figure out what the load is going to be caused by rainfall on this flat roof, we have to get two things. First, we require the density of the precipitation, in this case for rain. So that's going to be approximately 9.78 kilonewtons per cubic meter. Okay? And this would have to be given to you, or you can find it if you have the ability to do so. 9.78 kilonewtons per cubic meter, approximate density of rainfall. And then you need to know the precipitation for the location you're looking at. Okay? If you go in the building code under the climatic resources, you'll find that the precipitation, in this case for Ottawa, you have different choices. The one that we're going to pick is the precipitation over 24 hours. Let's assume that it rains for 24 hours, and that's what we're expecting to design the loads and structure for. So for Ottawa, if you go check this out, you get 86 millimeters for 24-hour precipitation, because that's what we're going to pick for this, okay? We're picking the 24-hour precipitation. Okay? So now that you have the density of rain and the expected precipitation, right? This is the one that you usually hear on the news or in weather bulletins. In our case, we're picking 86 millimeters for 24 hours. What do we do? How do we figure out what the distributed area load is going to be on the roof, right? Because that's what we're going to get, right? After we get 86 millimeters everywhere here, it's basically a force that's distributed over the whole area of the roof. So we're looking for something in kPa. And if you remember, kPa is kilopascals, which is also kilonewtons per meter squared. So somehow we have to use these two to get kilonewtons per meter squared. So what we're going to do is we're actually going to multiply these two. Okay, so I'm just going to put a multiplication sign between the two, like this. But in order to make that work, we have to get the units to work out. Let me show you why. If we do density times precipitation, we get 9.78 kilonewtons per cubic meter times 86 millimeters. These units don't work out. Either we need to convert this meter cubed to millimeters cubed, or this millimeter to meters. That's the only way that we're going to get this to work out so that it balances out to give you kPa. So in this case, I choose that I'm going to convert 86 millimeters to meters. All right, there's a lot of ways of doing this. I'm just going to do it super quickly like this. I'm reminding myself that 1,000 millimeters equals to 1 meter, right? Which is great because this and that cancels out. And then look at this. Meter and meter cubed balances out because then it becomes meter squared at the denominator. So what we get, if we do this work here, is 0.841 kilonewtons per meter squared. Whoops, meter squared. Which is great because we know the kilonewtons per meter squared is also kPa. Right? So then I'm just going to make this obvious and unmistakable. Therefore, rain load, according to this very simplified method, 0.841 kPa. And then I make this obvious and unmistakable, just like that. Right, so super easy. The only thing for this very simple method to figure out the load on our roof due to rainfall, we need the density of rain. I gave it to you as 9.78 kilonewtons per meter cubed. And then the expected precipitation we're going to use to design this roof. I chose to pick Ottawa, the 24-hour precipitation, which came out to be 86 millimeters from the Ontario Building Code. Okay, I hope this worked out. It's meant to be as simple as it looks. Thank you so much for your time, and take care.